and DevOps hands-on implementation series. We are at episode 8 and today we are diving into the networking basics with Amazon VPC, which stands for Virtual Private Cloud. I am Sagarika Ghoom. Now, I know networking might sound a bit tricky, but you don't worry about it. I will walk you through it step by steps. In this session, we will look at how AWS gives you complete control over your network, including IP ranges, subnets, and how you manage the inside and outside flowing traffic in your network. Whether you are launching a web app or managing a secure backend system, VPC is the foundation. So let's get started. Let's start at the very beginning. What is a VPC? A virtual private cloud. VPC is your own private isolated virtual network within AWS. Think of it like building your own secure data center but in the cloud and with way more flexibility. So what makes a VPC so powerful? Control. Control is the main word. You get full control over your network environment. That include IP ranges. IP ranges means you decide the CIDR blocks which define your IP space. For example, you can have a 10.0.0.0/16 range and break down into smaller subnets. Subnets are these help to logically split your VPC into smaller zones, often across multiple availability zone for high availability. Third one is the route tables. This define how traffic is routed between subnet or out of the network. Fourth one is gateway, such as internet gateways for internet access or NAT gateway to allow internal instance to reach out to the internet securely. Fifth one is security groups and network ACLs to define the fine grain traffic rule. Imagine you are building a multi-tier web application. You can create a public subnet that hosts your web servers accessible from the internet, then a private subnet for your databases only accessible internally. Use NAT gateways to allow private instances to fetch updates from the internet without exposing them. You can even connect your on-premises network to VPC using AWS Direct Connect or VPN, enabling hybrid cloud setups. And here is the best part, it scales automatically. Whether you are running a small app or a full-scale enterprise service, VPC adjusts your needs. In short, VPC gives you the foundation to build secure, scalable, and well-architected cloud infrastructure. Here you can see the diagram of VPC, means here is region. In that region, there is a virtual private cloud, and in that virtual cloud, there are three subnets. And in VPC, this is the internet gateway for internet access, and in the subnets we have created one instance in each subnet, and these are all in different availability zone. So you can get idea about what is VPC from this diagram. Now that we are covered with what a VPC is, let's look at the key components that make a VPC. These are the building blocks that define how your cloud network behaves and how secure and scalable it can be. First one is the subnet. Subnets are the segments of your VPC IP address range. They let you to group and organize the resources logically, like EC2 instances, databases, and load balancers. Each subnet resides in a single availability zone, helping you to design for fault tolerance and availability. We will talk about public versus private subnet in the next slide. Then second one is the route tables. This act like a GPS system for your network. Each subnet must be associated with a route table that determines how traffic flows, whether it stays inside the VPC or goes out another VPC or exits to the internet. You can create custom route tables and associate them with the specific subnets to manage the traffic flow precisely. Third one is the internet gateway. In short, IGW. This is the horizontally scaled, redundant, and highly available gateway that enable communication between the instances in your VPC and the internet. Basically, it is for communication purpose, means communication between internet and your VPC. It must be attached to your VPC and reference in the route table to allow the outbound internet traffic. Fourth one is the NAT gateway. This component enable instances in a private subnet to initiate outbound connection to the internet. For example, downloading software updates while still remaining unreachable from the outside world. It acts as a proxy in a public subnet, handling all the internet-bound traffic from your private subnet instance. But keep in the mind, NAT gateway charges you. Fifth one is the security group. Think of this as virtual firewalls for your EC2 instances. They control inbound and outbound traffic at the instance level and are there stateful, meaning response traffic is automatically allowed. I have shown you about security groups in EC2 instances. I hope you remember about the security groups. Then sixth one is the network access control list. These are the stateless firewalls that operate at the subnet level. You have to explicitly allow both the inbound and outbound traffic. It provides another layer of security on the top of security groups and are especially useful in tightly regulated environment. And other key elements are elastic IPs, static public IP addresses you can attach to resources in the VPC. Then VPC peering. It is a way to connect two VPCs privately over the AWS network. VPC endpoint. It lets you to connect privately to AWS services like S3 and DynamoDB without using internet. And all these components work together to give you granular control, flexibility, and security over your AWS networking environment. Let's break down the difference between public and private subnets. This is the crucial for designing your network. First one is the public subnet. Direct internet access is must for the public facing servers. Then route table point directly to the internet gateway, which give them inbound and outbound access to the internet. Use cases are you typically put things like web servers, load balancers, and the host in public subnets. Then about private subnet, this do not have direct access to the internet. If they need it, it has to go through a NAT gateway. Points route table points to the NAT gateway or doesn't point to anything for isolation purpose. Use cases are perfect for backend services like databases, application servers, and Lambda functions that don't need to interact directly with the web. The reason for segregation is security. Public subnet are exposed to the internet, so you need to manage them carefully. Private subnet are secured from the direct external access, but they still have to access the internet when necessary. So public subnet has internet access via internet gateway, and private subnet has internet access through NAT gateway. Let's now look at the how routing works inside a VPC. Routing is what determines how traffic flows both within your VPC and to the outside world. Each subnet is linked to a route table which hold the rules that define where traffic should go based on the destination IP. Common destination and their targets include local means it allows the communication between the subnets within your VPC. This route is always present. Then internet gateway for outbound and inbound internet traffic, typically using public subnet. Then NAT gateway for private subnet that need outbound internet access like downloading packages or updates but should remain inaccessible from the outside. Then VPC peering or VPN gateway for connecting to the VPC or on-premises networks. Then VPC endpoints for privately accessing AWS services like S3 or DynamoDB without touching the internet. For example, a web server in public subnet needs a route to 0.0.0.0/0 pointing to the internet gateway to allow internet access. A database in a private subnet needs a route to 0.0.0.0/0 pointing to the NAT gateway for safe outbound only internet access. The route table is like your network's traffic map, helping you to control access, improve the security, and ensure smooth communication between the resources. Alright, now let's move on to the hands-on part. How to actually set up a basic VPC for your application. This will give you a practical foundation for launching resources in a secure and well-structured network. First of all, we will create a custom VPP, then add subnets, then we'll attach internet gateway, then we will create route tables, and then launch EC2 instance in each subnet. And this diagram show you how this VPC network built. This is the VPC, subnet, route table, and network connections. So log into your AWS console, search for VPC. Now click on create VPC. Select VPC only. Name your VPC, for example, my app, VPC. Set IPv4 CIDR block to 10.0 10.0.0.0/16. Leave other option default and click on the create VPC. You successfully create the VPC. This is our VPC ID. Now divide your VPC into smaller subnetworks. Go to the subnet in the left side of this dashboard. These three are the subnet created by default. Click on the create subnet. In VPC ID, choose your VPC ID. You can see your name here, my app VPC. Click on this. IPv4 address is this. For subnet name, give name my VPC subnet 1. Availability zone, give Asia Pacific AP South 1A. Name it the and CIDR block is 10.0.1.0/24. Give name to the subnet public subnet 1, and the availability zone is AP South 1A. Click on the create subnet. Then again click on the create subnet, select VPC ID, give subnet name private subnet 1. Availability zone, choose AP South 1B CIDR block 10.0.2.0/24. Click on create subnet. Now these two are our subnet. This is public subnet and this is private subnet. Now we will create internet gateway. Go to the internet gateways. Click on create internet gateway. Give name my app IGW. Click create. Then attach to the VPC. Select your VPC and then attach internet gateway. Internet gateway successfully attached to the VPC. Now we will create route tables for public subnet. First of all, click on the route tables. First of all, we will create route table for public subnet. Click on the create route table. Give name public route table. Select your VPC. Then click create. Now go to the route tables. Click on your route tables. Go to the routes, edit routes, add route. Destination is 0.0. Target is internet gateway. Give your ID. This is our internet gateway. Save changes. Go to the subnet association. Edit subnet association. Then select public subnet 1. Save association. So what we have done, we have created route table, then attach internet gateway to this route table and add public subnet. Now we will create another route table. Click on create route table. Give name private route table. Select your VPC ID. Click on create route table. Go to the routes and edit routes. Add route. For this is for public subnet, so we don't have to assign this. Go back to the route tables. Click on the subnet association. Click on the private route table, then click on the subnet association, edit subnet association, and then click private subnet, save association. So we have attached private subnet to the private route table. So no internet access route is added for the private subnet in this setup. Now we will test our setup by launching EC2 instances. Now go to the EC2 dashboard. We will launch instance first of all for public subnet. Give name public instance 1. Select Amazon Linux 2 AMI. then t2.micro, then select your key pair, then in network setting edit, select your VPC, that is my app VPC, select your public subnet, make sure to assign public IP, enable, create, configure the security group to allow SSH and HTTP, select existing security group or create security group, SSH anywhere, add another security group, that is HTTP anywhere, okay, and then launch the instance. Now repeat same step for private subnet, create EC2 instance for private. So for private instance, give name, select Amazon Linux 2 t2.micro key pair, click on the network setting, select your VPC, assign private subnet 1, and do not assign public IP. This should be disable. Add security group, HTTP anywhere, then click on launch instance. Now the two instances are created. Now we will test both of these instances. We will connect these two instances with SSH. First of all, we will connect to our public instance. Copy public IP, go to the command prompt, connect your instance. Type this command to connect your EC2 instance. Yes, we have successfully connected to our EC2 instance. Try to browsing the internet or ping a public IP. This should work. Type ping google.com. This should work because it's in the public subnet, which has direct route to the internet via internet gateway. Now we will connect our private EC2 instance. Then we will see how we can access this network. Now copy your public IP of private subnet. We don't have any public IP to the private instance, so because we have disabled that, now click on the private IP, copy it, copy here. See, it will not work because we don't have internet access to this EC2 instance. Connect to the host, connection timeout. We doesn't have any route to the internet gateway, that's why this won't work. And you are done. You have now a VPC with a public subnet connected to the internet gateway via an internet gateway, private subnet that is isolated from the internet, and the EC2 instances running in both subnet, showing how public instance can access the internet while private instances cannot. This setup is simpler and doesn't require a NAT gateway, making it more cost effective if your application doesn't need internet access from a private instances. Now go to your VPC. This in the resource map, you can see this connection. This is our VPC, my app VPC. We have two subnet, public subnet, private subnet with two availability zone. Public subnet is connected to the route table, and this private subnet connected to this private route table, and this public route table is connected to the internet gateway. This is our VPC, means virtual private cloud. As your AWS network grows, you will want to explore more advanced VPC features. These features as VPC peering. This allows you to securely connect two different VPC in different region or AWS account. It is perfect for application with multiple VPCs. Then VPC endpoints. This can access AWS services like S3 or DynamoDB without using the internet. This helps you to reduce the latency and improve the security. And another one is the transit gateway. If you are managing multiple VPC, your transit gateway acts as a hub interconnecting your VPC on premises networks and other cloud network. Then VPC flow logs, this track and log all network traffic. This is incredibly useful for security monitoring, troubleshooting and auditing. These advanced features give you flexibility, security and scale. Then default versus custom VPC. Most of the time you will be working with custom VPCs rather than the default one AWS provide. But what the difference between them? Default VPCs are created by AWS and custom VPCs are created by us. Then these default VPC are internet ready. Custom VPC we have to configure it. CIDR range for default VPC, these are the fixed, and for custom VPC we can choose it. Then use cases for default VPC is for quick testing, and the custom VPC are production environment. A default VPC is a nice for quick experiment, but for a serious production grade workload, you need the flexibility and security for a custom VPC. Alright, that's a wrap up on today's session. To recap, you have learned about the key components of VPC, subnets, route tables, gateways, security groups, and more. You saw the difference between public and private subnet and how to route the traffic efficiently. And we did a hands-on walkthrough of setting up your VPC from the scratch. In the next episode, we are diving into auto scaling and load balancers. We will cover how to scale your application and handle the traffic spikes while keeping everything highly available. You don't want to miss this one. As always, make sure to like, share, and subscribe to stay up to date on the latest in the cloud and DevOps content. Thanks for the watching, and I will see you in the next one.